Hi friends, I'm a big fan of old electronics and recently my acquaintance brought beautiful, unusual flashlight. The guy who brought this works under contract in the army. The flashlight is old and he asked to convert it into an LED and put the battery. Looking closer at the flashlight, it became clear that it was a French production in the 1980s. The body is metallic, but there are some plastic parts. Most likely, this flashlight is for civilian use. Were also army models, but those were usually supplied with additional filters for signal operations. At first glance, it became clear that the flashlight was a completely new, with bright green color and genius simple design. I couldn't resist the temptation. I promised to collect other flashlights if he gave me this one. I had only a few hours, so I had to work quickly and thoughtfully. So, as a flashlight for army use, it should differ strict, simple design, and of course, reliability. It was decided to add solar charging, getting a literally eternal flashlight. First, I specified some details from my friend. It became clear that the flashlight should work from 3 to 6 hours and guarantee long-term operation at sub-zero temperatures. Also, be reliable and resistant to mechanical damage. It is possible just to put the battery and LEDs, but I like to complicate everything. Here is a flashlight circuit. This is a normal auto-generator boost converter. Why is it needed? The matter is that, as a power source, I decided to use a nickel-metal hydride battery. It is frost-resistant, has a long life service, and a minimal memory effect in comparison with the nickel-cadmium batteries. The trouble is that, for the normal power supply of conventional 5mm LEDs needs 3 such batteries, which I didn't have at the moment, so the converter is used, which raises the voltage from the battery to the desired value. The converter is built only on one bipolar transistor of reverse conductivity. In my case, it is a transistor TIP41. The output current of such a converter can reach up to 300 mA, which is more than enough to supply the number of LEDs that I use. The step-up transformer is wound on a ferrite ring. The size of the ring is now in front of you. The permeability is 2000. Both windings are wound with the same wire and contain 20 turns each. A wire diameter is 0.8 mm. They are connected in series to form a midpoint. The bursts of self-induction from the power winding of the transformer are rectified by a Schottky diode. In my case, it is a conventional pulse diode, but I advise you to put the Schottky. Then the capacitor is smoothing voltage, which fed to the LEDs. The inverter starts working at an input voltage of 0.4 volts. From 1.2 volts, consumption is about 80 to 90 mA. Correct operating voltage range is up to 3.5 volts. I used 9 light-emitting white LEDs of 5 mm. This connection is not quite correct since the brightness of the LEDs will be different. It is very desirable to use equalizing resistors for each LED, but all of my LEDs are from the same lot and brightness at the same supply voltage is almost the same. The transistor doesn't overheat, so there is no need for a radiator. A few words about the solar panel. Unfortunately, the only suitable solar panel that I could find was giving out voltage of 5.5 volts, and the current is only 30 mA. Ideally, it was necessary to lower the voltage from the panel to 1.5 volts, which would be enough for a normal charge of the battery. But I did the other way. I just put the protective diode. The charge current is miserly and will not hurt the battery. The circuit board was created taking into account the dimensions of the casing. The tracks were additionally soldered. The transformer was later to be sealed from the backside and fixed with epoxy resin. The solar panel was glued in the same way. It turned out a very reliable design and it shines quite well. Friends, I remind you that you can find a link to the archive with the circuit and PCB in the description. If this video was useful, don't forget to evaluate it, share with friends in social networks. Have a nice day! With you was Kasyan TV.